Good morning. Today we are going to talk about second degree polynomials, otherwise known as quadratic equations. So we'll use the example today of, let's say, x squared plus 5x plus 6. Now we want to factor this this function. Let's say this is a function of x, and we want to factor this thing into the form of x plus a times x plus b. Now when you multiply this back out, you have this equals x squared plus xa plus xb plus a times b. And this is equal to x squared plus, we'll factor out an x out of these two middle terms because they have a common factor. So here's our x and a plus b plus a times b. Now, the terms that corresponds, let's say this 5 right here corresponds to this a plus b. So we're going to go over here and just write a plus b equals 5. And this term right here, the 6, corresponds to the a times b over here. So we will go over here and write a times b equals 6. Now what we want to do is we want to find the common factors of 6. So we can just write those down right here. Just 1, 2, 3, and 6. These are all the numbers that multiply evenly into 6. So we want to find two of these numbers when added together equal 5. So clearly we have 2 and 3 here. So a plus b equals 5, 2 plus 3 equals 5. And when you take these same two numbers, 2 and 3, and multiply them together, we have 6. So we have our match here that will work. So when we put it into the x plus a times x plus b format, we have in parentheses x plus 2 times x plus 3. And this is equal to 0 because this whole term, this factor right here, is equal to this x squared plus 5x plus 6 is a function of x, so thus it's equal to 0. If we wanted to graph this now, first what we would have to do, let's just draw a graph here. So here's our y-axis and here's our x-axis right along here, this horizontal one. We want to find out, well, first off, the general shape of a second degree polynomial. And this function is a second degree polynomial because one of the variables here is raised to the second power right here. And the general shape of x squared, a second degree polynomial, takes the form of a parabola. Well, it is a parabola. And it basically looks like this. This is a rough graph of x squared. But we have x squared plus 5x plus 6. So we want to find out where does this graph intersect the x-axis. And we can find these points by simply setting these two here equal to 0. So we have x plus 2 is equal to 0. And so we'd have to subtract 2 from both sides. Move this over here, and we have x equals negative 2. This will be one of our x-intercepts where the graph crosses the horizontal x-axis. And the other one right here, same thing, x plus 3 equals 0. So we'll subtract 3, and we have x equal to -3. So let's go over to our graph here, and we'll just eyeball. We'll mark -2 right there, and we'll mark -3 right here. This isn't exactly to scale, but you get the idea. So this graph is going to come down and intersect, pass through the graph right there, come back up right there, where it will shoot off into infinity on both sides. So this is once again a rough graph of what this function will look like, where it intersects at -3 and -2, and that is how you factor a second degree polynomial, otherwise known as a quadratic equation. And this is how you graph it here. You find your x-intercepts and go from there. Thank you for joining us, and we'll see you next time.